So I just got a YouTube message that says, does 0.9 repeating equal 1? And can I prove it? The answer is yes, and yes. So I can really prove it 3 ways, and I'll show you all 3 proofs. So, the sort of silliest way, I don't know if it's silly, I mean it's not very fun, is that 1/3 is equal to 0.3 repeating. And then there's this thing called the multiplication property of equality, which says you can multiply both sides of an equation by the same non-zero constant, and you get an equivalent equation. So what if I multiply both sides by 3, for instance? So I'll multiply this side by 3, and this side by 3. Well, 3 times a third is 1, and 0.3 repeating times 3 is 0.9 repeating. So 1 is 0.9 repeating. Okay, so that's sort of maybe the easiest way to think about this. One that's slightly more fun is to say let x equal 0.9 repeating. And then by the same property, the multiplication property of equality, we can say then 10x is equal to 9.9 repeating. Right? Multiply both sides by 10. Well, then what we can do is we can subtract this equation from this equation. So we can say, all right, we can say 10x equals to 9.9 repeating minus x equals to 0.9 repeating equals. 10x minus x is 9x, and 9.9 repeating minus 0.9 repeating is 9. We divide both sides by 9, we get x equals 1. Oh, therefore, 1 is equal to 0.9 repeating. Okay, so that one's a good one. And then the last one requires us to know some Algebra 2, specifically stuff about geometric series. And so I'm going to skip a huge chunk of math here and talk about a geometric series. A geometric series is a series of the form a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed, all the way to infinity. And if you add up all of these things, and r happens to be less than 1, so if r is less than 1, and you add all of these things up, it's equal to a sub 1 over 1 minus r. So, pretty sure Gauss came up with that. Not really sure though, but so I skipped a big chunk of math there. So for now, you're just going to have to believe me on that, or maybe search for the proof elsewhere, or maybe I'll prove it another time. So the sum of a geometric series is a sub 1 over 1 minus r. So what we're going to do is we're going to look at this series, 0.9 plus 0.09 plus 0.009, right? So this is, I'm going to keep adding this extra 9, right? Like ad infinitum, like forever. And so this is going to be a sub 1 is 9/10, right? So 0.9 is 9/10 over 1 minus r, and r is this ratio between the two terms. If you take some term divided by its previous term, you get r. r in this case is a tenth, right? So if I multiply 9/10 by a tenth, I get 9/100. If I multiply 9/100 by a tenth, I get 9,000ths, etc. So r is 1/10. So I have 9/10 over 1 minus 1/10, which is 9/10 over 9/10, which is 1! 1! Right? So this thing is 0.9 repeating, and when you sum a geometric series, you get a sub 1 over 1 minus r. Trust me. And then we see that that's exactly 9/10 over 9/10, which is 1. So yeah, 0.9 repeating is equal to 1. It's a neat little thing, and a lot of students think that it's weird when they first see it, but yeah, it's not rounded up to 1, not approximately equal to 1. It is exactly equal to 1.